Hi there again. Now we're going to continue with the next little section in Financial Maths grade 11, and that is going to be effective and nominal interest rate. Now this little one is such an important little section. It's actually easy when you have certain points that you can hold on to and certain principles that I'm going to help you with today. I'm going to start with a simple example and then explain the concept between effective and nominal. Then we're going to get your formula and then do some examples. That's where we're going. So let's start off with a simple example. Let's say, for instance, 20,000 Rand is invested for 1 year at 18% per annum compounded, both annually and monthly. So if it's compounded annually, we are going to end up with 23,600 Rand. Okay, remember our compound interest formula. If it's compounded monthly, remember it's your original amount, your 20,000, 1 plus your interest rate, which is 18% per annum, 0.18. But if it's compounded monthly, remember there are 12 months in a year. So in 1 year, that 18% has to be divided by 12. But in 1 year, there's 12 months. So at 12 different time periods, we're going to be charging interest. And that produces 23,912 Rand. Now, as we know, the one that's compounded monthly will produce more because you are charged, there's more end values that's compounded monthly as opposed to just interest worked out annually at the end of the year. So now what I want to do is have a look at what if I took this amount here as my final amount and just charged interest once, in other words, compounded annually, but to end up with this amount here. And we're going to work out that new interest. So my unknown is the interest. And I wonder, before we look at the answer, if you think that that new interest is going to be more or less than 18. Let's have a look. So I want to end up with 23,912 Rand, blah, blah, blah. Starting off with 20,000. I want to know what my interest rate would have to be if it was compounded annually, and I wanted to end up with that amount. So you know the drill, you divide by 20,000, you subtract the 1, etc. And we ended up with a rate of 19.56%. In other words, if I wanted to end up with, whether it was compounded monthly or annually, I'm getting too excited. I wanted to end up with 23,912. That would mean that my effective interest rate would have to be 19.56% in order to end up with the same amount if I was compounding it monthly. Now that's the difference. Effective is also is the interest if you're only doing it once a year, compounded annually. That's effective. Nominal is when you are compounding quarterly, monthly, etc., etc. So now, in terms of this example here, this 18% is going to be your nominal interest rate, and this 19% is going to be my effective interest rate. Because what essentially is happening is you're wanting to end up with the same amount, but very seldom in real life is it compounded annually. It's always compounded in smaller periods of time. But if you wanted it compound annually, what would that effective rate be, which would end up producing the same amount? So bear with me as we keep going. I'm now going to show you the formula for this and where it comes from. It's not on your formula sheet. So this is a formula you have to remember. And once again, remember, if you understand, then you will remember a little bit better. Okay, we're going to carry on here with this effective and nominal interest. Now with the example I was using, we ended up with the amount of 20,000 after 1 year growing to 23,912 Rand and a couple of cents. Now what I want to look at is this would be the effective interest, because in this particular case I invested 20,000 Rand and it grew to 23,912 Rand over 1 year, compounded annually, and my interest rate I worked out was 19.56%. We want to write that as, I want to stick with our proper, correct way of writing the interest rate. Whereas on this side now, this was our nominal interest rate, and that was 20,000. Started off, invested that. My interest rate in this case was 18%. It was compounded monthly, so it was divided by 12, and because there are 12 months in a year, there were 12 time periods in as 12. Okay, and if I equated these, I got the same amount. Now this case here, this would have been our nominal interest rate, 18, and then I essentially worked out the effective interest rate by using that same amount, and I ended up the effective interest rate was 19.56%. Now herein lies the formula, because we want the effective interest rate to be equal to the nominal interest rate always, and it's always over 1 year, only over 1 year. So essentially, if I've got an equation, I can get rid of the 20,000 here, and I can get rid of the 20,000 here. I'm dividing both sides by 20,000. And what am I left with? I'm in effect left with 1 plus 0.1956 to the power 1. And that's going to be equal to 1 plus 0.18 over 12 to the power 12. Now, if I want to make a formula from this, my effective interest is going to be always 1 plus my effective interest, I'm just going to write like that, whatever the effective interest is. And on this side, my formula is going to be 1 plus whatever the nominal interest rate is over the number of time periods in 1 year. And over here would be the number of time periods in 1 year. And there's your formula. That's your formula for converting effective to nominal or nominal to effective. And this is very important to remember. So this is not on a formula sheet. This is a formula you have to remember. Now, I've had some people ask me, can't I just take, because it's the equation, can't I remove 1? But we can't. Why? Because if you look carefully, that m, that exponent m, refers to the whole bracket. So we can't just remove it. And secondly, there's 2 terms within this equation. One little comment is, what do these stand for? So this stands for the effective interest rate. The effective interest rate in this case was 0.1956. Here, this is the nominal interest rate, which in this case was 18. What does the M and M stand for? The M stands for the number of time periods in the year. So this M is the number of time periods in the year, and then this would be the number of times that you charge the interest, which is the same as the number of time periods in a year. It's always 1 year, 1 year. Effective is always 1 year. Okay, so now let's have a look at an example of how we would use this. Ta-da! Okay, let's look at some examples now with effective and nominal interest and the transferring from one to other. Okay, so if an interest rate of X% per annum, compounded monthly, is equivalent to an effective rate of 8.75%, calculate the value of X. Okay, now remember, it's always important to read things a few times to understand them. So if an interest rate of X% per annum compounded monthly, now because that's compounded monthly, it straight away tells me that that is the nominal percentage. And if it's equivalent to an effective rate of 8.75. Okay, so our starting point is the formula. We write down the formula. Now, it's an equivalent to an effective rate of that. So we know that our effective interest rate is 0.08. Oopsie, let's just get rid of that. 8, no, that's also wrong. What I meant was 0.0875. That's our effective. Now, what we want on this side is we want to work out the nominal. We don't know what it is. But they do tell us that it's compounded monthly. So in 1 year, I have to divide whatever the interest is by 12, and then it is charged 12 times. So now we're going to work backwards, and we're going to have a look at what this is. So what I do here is hopefully you'll understand as I'm trying to look for this nominal interest. So the first thing I do is I get rid of the 12. So I'm going to take the 12th root, and then I'm going to subtract 1. And I'm left with R nom over 12. So let's work Let's work with this together. So I'm going to go, first going to switch my calculator on. And then I'm going to go the 12th root of 1.0875. And I'm going to subtract 1. And I get 0.00701 blah, blah. And I end up with this. Now, if we keep working, let's see if we agree. So now this number here, I'm going to multiply by 12. So I go times 12. And then once again, because that is going to be my interest, I want it in rate, I'm going to times by 100 to get it to percent. And my nominal interest rate is 7,014, so 7,01%. Okay. So once again, we have got this here is our effective interest rate and this here is the nominal. The effective interest rate, by the way, is always going to be higher than the nominal. Okay, let's have a look at a second example. Which interest rate would you choose if you were presented with the following options? Presented with 14% compounded semi-annually, or 13.2 compounded monthly. Now, essentially, those are both nominal interest rates. This is nominal because it's semi-annual, and this is nominal because it's monthly. Now, the only way I could really compare these two if I got them both to effective. So I could find the effective of this one and the effective of this one and compare the effective interest rates over 1 year, and then I would be able to work out the answer. So let's start off with my formula. 1 plus interest effective, help me, is equal to there you go. I knew you'd get it. Okay, so I'm going to do this one first. So I want 1 plus interest effective is going to be equal to 1 plus, what was it? 14, so that's 0.14, and that was compounded semi-annually, so it's twice a year. Let's do the next one here as well, and then I'm going to have 1 plus interest effective is equal to 1 plus, what was this? 13.2, so it's 0.132, and it's compounded monthly, so it's over 12 to the power 12 because it's charged 12 times in 1 year. Okay, so now if I want the interest of effective, I'm going to have to work this out, which is in brackets 1 plus 0.14 to the power 2. And then don't forget, I'm going to have to subtract the 1 because this 1 must go across. And I'm going to end up with 14.5% to 1 decimal place. Let's have a look at this one. You do it on your calculator as well and see if you agree with me. And then we close brackets, and that's to the power 12. And we get here, don't forget, you must also minus the 1. That's what people often forget to do. Here I get 14.02, so that's just 0.0, rounded off to 1 decimal place. So now, essentially, this is so close, but the effective interest here is 14.5, and the effective interest here is 14.0. So which interest rate would you choose if you're presented with the following two options? Okay, well, we can assume that if this is an investment, I think I would want this one because it's higher. So I would choose this answer. Okay, if it was not an investment, but if it was a loan, that's just for interest. Let's look at this. If it was a loan, then I would probably choose this one because the effective interest is lower. Okay, so there we have two examples. You go and look for some more in your textbooks or whatever resources you use to practice a few more when you change nominal interest to effective interest or effective to nominal, and look for some other practical examples as well. Good luck. You have got this.